Today's quiz picks up on this table that was created in another quiz. And today we're going to be talking about binary counters. Let me hold this up and I'll read it. It's a long one today. It says, a counting circuit has output LEDs that show the state of the circuit as it counts to 16. The table below shows the outputs given by the LED lights. Can you determine how this circuit is counting? In other words, what is the algorithm for QA, QB, QC, QD? Remember, this is a binary counter, and QA, QB, and QC, and QD must contain the number 2. That's a lot. Let me show you where this comes about. I have a counting circuit, and our quiz today is going to ask you how this is actually working. And if you stick around later on in the video, I'll show you how to make this. But on our table here, we have our LEDs representing our Qs, our states. Now, where Q comes for output state, it's been said that Alan Turing came up with it to represent quanta. And remember, we're talking about ones and zeros, ons and offs here. That's really how our chip is going to be working for counting. So how do we get that to happen is really what we're asking. In other words, what are the values that must be here? And so that's what our quiz is really asking for today. I'm going to show you physically how this works by connecting this circuit. And I just have a counting chip. Technically, this is a 4-bit synchronous up-down binary counting chip. We don't need to worry about all that. All you really need to remember is it's binary states. And when I go to show you how to build this, I imagine we're going to run into a problem first that will lead into something else. But let's just try to turn this on. And this is how computers essentially count. So let me put this on. And I'm at number 1 here. Now notice this bulb, I guess I could put it up like this instead. So number 1 would be lit up indicating 1. So when we go to number 2, the next bulb down should illuminate. Let me see if that'll work. I'll try and get a clean count, and I do. And you'll see when you make a switch on and off, much harder than you would ever think. So now I've got number 2 here. 3 is when I push the button again, and I've got 3 illuminated here. Both state A and state B are illuminated. Now I'm going to go to number 4, and that is going to be this third bulb will light up. Let me see if I can get it. Nope, see, that's the problem. It missed 4 and went right to 5. So 5 is going to end up being state C and state A together, which would make 5 total. Now, you might be wondering, how hard is it to push a button once? You would not believe the difficulty that engineers have to deal with in trying to get a clean pulse. We'll show you that later on. But for right now, we want you to see that this is how this counter is working. Every time I push the button, it counts, and that would be 15 with all the bulbs lit up. And then if I press it one more time, it missed it. It counted all the way up to 3 already. It is going to be blank for 16. See, look, before we go on, let me just explain this so it doesn't seem too crazy. Whenever you are trying to get a switch to touch one piece of metal with another piece of metal, there's a big problem. This is a touching problem. In other words, we think when you touch something, you're physically, somehow touching. But when you really think deeply about this, you're bringing your atoms together. And atoms have, we'll say, electrons going on the outside. And as they get closer and closer and closer, when do they actually touch? It's not as simple as you think. And then you put oxides on these switches, and it becomes a serious problem. So I might actually have to modify this circuit and make another circuit that will send clean pulses. So this will get clean pulses so it can always count without mishaps like we're having here. Regardless, give your students some time to think, what is the algorithm that must be in there for a binary condition to be able to count up to 16? That's your quiz. Let's give them a try. All right, your students are trying, they're thinking, and they're trying to figure out how they can create all this with states that essentially are ones and zeros, ons and offs. A few might have had computer science or something like this if they're advanced, but regardless, it's still going to be a challenge. Most of them will say, like, look, if I've got an output with this Q, oh, by the way, others have said that you can have a 0 and a 1 put together, kind of like a Q, a line and like the 0 state and the 1 state. Just another idea for what Q comes from. Regardless, we can say, look, I get that it's binary. There's 2 options. That 2 makes sense there. And in fact, 4 makes sense because somehow I've got 2 2s. And they're really onto something. Keep encouraging them. But the thing that is really going to get them is, how do you get 1 from 2? How do you take a half or something like that? So students are going to be thinking in this manner. Just keep encouraging them. Hopefully they're going to get this. Hopefully your students have really gotten into this. They all know that 2 must be involved. Heck, we gave it away in the actual quiz. We say they have to use a 2. So I'm going to put a 2 in here, right? And we'll just start off with that. We can end up saying, well, before that, we know that this one has to be 2, right? This is our number 2. But how do we make the rest of these somehow have a 2 in there? Some will say, look, you take 2 once, 2 twice, and then 2 times 3 would be 6. So that doesn't work. Someone else will jump up and say, no. Look, if you took 2 times 2 times 2 again, in other words, 2 3 times, if you use the exponents, that'll work. Look, 2 to the 3rd power versus 2 to the 2nd power and 2 to the 1st power. So 2 raised to the power of 1 is 2. 2 raised to the power of 2 is 4. 2 raised to the power of 2 raised to the power of 3 is 8. The one that a lot of students forget, though, is that 2, or any number, raised to the 0th power is still 1, and that's the answer. It's the exponent. So just a really cool way of getting your students to start thinking about how coding and computers and mathematics all come together. All right, that's your quiz, but if you want to stick around, I'll take you through how to make this little circuit here. Let's show you how to end up making the circuit that can count binary. This is what I was using. A lot of wires. It looks complicated. It's not at all. First thing you want to do is get some kind of chip. And these little chips have legs on the bottom of them. And that's what I have represented right here. Let me get my marker. And they'll normally have on the top of them, there's going to be like a little cutout. I don't know if it'll show on the camera, but up at the top there's a little cutout. Looks something like this. Or they'll have a dot, something. And I know most physics teachers, or science teachers, I should say, haven't built a circuit. So I'm going to make this as simple as possible. If you're more advanced, you already know how to do this. But look, whenever you take your chip, and you don't need a breadboard. A breadboard would be a nice feature, but you don't have to use these. You can literally, just hook little leads up to them, and this will work fine. Breadboards are convenient, but whatever your budget is, whatever supplies you have, the big thing is, don't be intimidated. Just try this out. I would use LEDs. LEDs are really cheap. Just so you know, they've got a long leg and a short leg. Long leg goes to the more positive side. And then we also have resistors. All you're trying to do is, because we're going to try and use like 5 or 6 volts. That's really a nice voltage to work with. Even if you have like a dead 6-volt battery and it's like 5-ish, it'll work fine. So if you can find some resistors, and we did a quick quiz on how to read those, and that was another coding issue. But this is a brown, black, brown. That's 100. I almost always just use brown, black, red. They're 1,000. They usually work fine. We call them 1Ks. I'd order a few of those and you'll be fine. Let's just jump right into this. So first thing, pin 16, whenever you take this, find your edge that has a little cutout. That's going to be our positive voltage, B, and I'll put positive. Connect that to the positive side of the battery. That's what we mean by that. And if we go down to pin 8, and if you haven't noticed, we start up and we end up counting counterclockwise. So this is pin 8, and that's going to be, I'll just call it 0 volts, or the negative side of the battery. So I'll just put 0 volts here, also known as the negative side of our battery. From there, we need to know our QA, QB, QC, QD. So we just start up here. This is going to end up being our Q, and this is A, Q, B, Q, C, and QD. Those are our outputs. And we want to run to little light bulbs. So what we're going to do is we're going to put a resistor, because this is, we'll say 5 or 6 volts, and we don't want to burn out our LED, some kind of resistor. And it doesn't really matter. If you get 100 on there, all the way up to like a 2,200, it doesn't really matter. Get something in there. Don't sweat about this. If you burn out an LED, it's not the end of the world. They're pretty cheap. So 4 and 5, and just so you know, I'm going to make this as explicit as possible. Let's say that we had my battery here, and I'll just use this battery. Let's say that this is the negative terminal, and that's the positive terminal. Literally connect 8 down to your negative. We can also call that a ground. Okay, so if we end up using a ground symbol, it means the same thing. Just connect it to the negative side of your battery. This is going to be connected to the positive side. And this isn't normally how you would draw a quality schematic, but if it gets you started, then we're achieving our goal. 4 and 5, these are normally going to tell, do you want it to count up or count down? I just normally take those directly to ground. And I'm using, what's the chip that I'm using is let's see, I'm using a 7400 series. So it's probably a 7.4. Let me see if I can read this. I can kind of make some of it out. 74. So it's a 191. If you get a 193, any of these. So let's just put 7, 4, L, S, 191. Okay, that's the chip that I'm using. But if you can find a 193, and if you can buy these for, you know, $1 each, or if you buy a bunch of them, hopefully they're going to be cheaper. Anything close to that, they'll come with some kind of sheet that will tell you how these work. I've used these for a while, so I just kind of know them. And then we'll just go to a ground symbol. So 4 and 5 on this circuit, I just put the ground. Now let's just take from each one of our pins through a resistor out to our LED. So let's take this one straight out, and then we'll just put a resistor, and then we're going to go to our bulb, and we'll say this one is QA, and then that's going to end up going to the negative side of the battery, which is ground. Look, we want B lined up here, so I'm going to take this one over, and then I'm going to just have it hop over here like this, and then I'll put a resistor, and then I'll make this QB, and then I'll bring my C and my D out here, just straight out, have them go through a resistor, just like we did before. That's QC. And then we'd have QD. And again, I would say use like, for the resistance, a 1K, 1,000 ohms. anything is going to be fine, right? If they're a little bit too bright, use a little bit more resistance and so on. Take all of these out. These are all going to just go right to ground. And in fact, I'll just draw them right to the negative side of the battery. Again, if you've built circuits, you already know all this, but we're really targeting those that have never built one before. And this would be a great little circuit to start off with. And when you put these together, it will light up once you tell it a signal. So let's give it a signal. Let's take any kind of switch, and you can physically just touch a wire. 14 is going to be what's called our clock. I'm just going to draw like a little switch right here. And I'll take that right to my battery also. So every time I touch that, it'll simply count just like I did before. Put all these together and plug it in, and hopefully you'll be able to start counting. And by the way, it doesn't know where to start often, so it'll just start wherever. But every time you push your button, hopefully it'll count. And remember, you don't need a button. You can just take your wires. All right, I hope that makes sense, and I hope I didn't leave anything out. There's other features on this, but the big thing is just try it. Just get started. I think once you build your very first counting circuit like this, you'll start looking for other things. And then maybe we'll show you how to put a 555 on here. So if this is our clock right here, if this is our input or our clock, I'll just use CLK here. What I can do is I can use a 555 if you're familiar with those. Pin 3, just take pin 3 directly over to here and don't hook it up to the battery. And it'll automatically count for you. I hope that makes some sense. That's your quiz for today. And above anything else, just give it a try.